LiDAR technology is the application of the remote sensing method described here. It is usually used to examine the surface of the earth, assess information about the ground surface, create a digital twin of an object, or detail a range of geospatial information. LiDAR systems harness this technology using LiDAR data to map three dimensional models and digital elevation. From handheld to airborne LiDAR, there's a LiDAR system to capture the data you need. LiDAR mapping uses a laser scanning system with an integrated inertial measurement unit and GNSS receiver or which allows each measurement or points in the resulting point cloud to be georeferenced. Each point combines to create a 3D representation of the target object or area. LiDAR maps can be used to give positional accuracy, both absolute and relative, to allow viewers of the data to know where in the world the data was collected and how each point relates to objects' terms of distance. LiDAR data in the form or a point cloud can be used to map entire cities, enabling decision makers to accurately pinpoint structures or areas of interest in millimeter perfect detail. Features and objects such as road networks, bridges, street furniture, and vegetation can be classified and extracted. LiDAR maps can also be used to highlight changes and abnormalities such as surface degradation, slope changes, and vegetation growth. There aren't many applications that wouldn't benefit from using LiDAR. From the games industry to Formula One teams, simulations based on 3D models are often used to give teams the edge before setting foot on a racetrack. Mapping, surveying tasks often require LiDAR systems to collect three dimensional measurements. They can create digital terrain and digital elevation models of specific landscapes. A digital elevation model is a three dimensional representation of terrain and all the objects within that space. Regularly spaced elevation values collected from LiDAR scans create a coordinate system that allows the Earth to be reflected and modeled with a high level of accuracy. Digital terrain models are just like DEMS without the objects included. They use LiDAR to map the terrain only. In architecture industry, laser scanning systems are popular for surveying the built environment too. This covers buildings, road networks, and railways. And in real estate, laser scanners can be used indoors to measure space and create accurate floor plans. In construction industry, it is also using LiDAR surveys increasingly. LiDAR technology tracks building projects and produces digital twins for BIM applications. It can also help produce 3D models for the conditional monitoring of structures and Revit models for architects and structural engineers. Environmental applications for LiDAR are plentiful. Laser scanning is a popular method for mapping flood risk, carbon stocks in forestry, and monitoring coastal erosion. And in automotive industry, LiDAR is also seeing increased levels of adoption for automation application. Smaller, low-range LiDAR scanners help navigate autonomous vehicles. And in space travel, if that wasn't enough, LiDAR data isn't only useful on Earth. It has been identified by NASA as key in enabling them to land lunar vehicles safely.